Hi, I'm Sushmita Bala, a senior software engineer with over 7 years of experience building scalable and high performance applications. Today, I will walk you through solid principles, which are fundamental guidelines in software engineering for creating maintainable, modular, and adaptable code. Single responsibility principle, which is the first one. So, the single responsibility principle states that a class should have only one reason to change, meaning it should address a single responsibility. In practice, this ensures that the code remains modular and easy to manage. For example, in a financial application, separating transaction processing from the validation logic allows updates to the validation rules without affecting the transaction processing code. So, this separation reduces the chance of introducing bugs and making the code easier to test. Open or closed principle. So, open or closed principle encourages classes to be open for extension but closed for modification. This means we should be able to add new functionality without altering existing code, which is crucial for scalability. For instance, user interfaces for various payment methods allows us to add new payment options without changing the existing structure. So this spatially valuable in microservice architecture, which where each service can extend functionalities independently. Third one, the Liskov substitution principle. The Liskov substitution principle says that objects of a derived class should be replaceable by their base class without altering the correctness of the program. In practice, this means a subclass should fulfill the expectations set by their base class. For example, if we have a bird base class with a fly method, a penguin as a subclass shouldn't inherit it, as it does not logically align with the expected behavior. So the following LSP helps maintain the logical consistency of the code. Coming to the fourth one, which is the interface segregation principle. Interface segregation principle suggests that the client should not be forced to depend on interfaces which they don't use. This principle is particularly useful for creating modular interfaces, especially in the complex applications. For example, in large system, instead of one monolithic interface for multiple functionalities, we can split it into smaller interfaces for each function. So this way, the classes can implement only the methods they need, reducing unnecessary dependencies and increasing flexibility. Coming to the last one, which is the dependency inversion principle. So the dependency inversion principle states that the high-level modules should not depend on the low-level modules, but rather on abstractions. So this principle fosters decoupling, making the system more adaptable to the changes. For instance, using dependency injection in the Spring Boot allows us to inject dependencies at the runtime, such as the database services, which makes the code easier to test and swap out the components when needed. So, all in all, the solid principles provide a framework for creating software that is scalable, maintainable, and resilient to change. By following these principles, we can build a robust system that are easier to extend and maintain, which is crucial in enterprise environments. So thank you for your time, and I look forward to discussing how my experience aligns with the requirements at Travel Science. Thank you.